Log m into n into p is log m plus log n plus log p, etc. Number of terms we will get. That's it. This is first law of logarithms. We will do the proof for this. So what is to prove? Log m to base n is equal to log m to base a divided by log n to base a. That is called base change rule, changing the base to a. What is the required answer? This is the required answer. Therefore, logarithm of m to base n is equal to log m to base a divided by log n to base a. This is called your base change rule. Okay, very important concept in this. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to take very important chapter and very easiest chapter, that is logarithms. Now, so before going to the exact chapter, let us know regarding the weightage for this chapter. So in this chapter you are going to get maximum 9 marks from this chapter. So you will have one mark question, one question for 1 mark and one question for short answer, that is one question for 3 marks, 3 marks 1 question, 1 mark 1 question and one essay type. So here one very short answer question is 1 mark, long answer 3 marks and essay type question for 5 marks. So 1 mark 1 question, 3 mark 1 question and 5 marks 1 question. Totally you will get 9 marks. So one very short answer question is 1, that is for 1 mark, and then lengthy answer for 3 marks and essay type answer for 5 marks. So total you will get 5 plus 3 plus 1, 9 marks from this chapter. Now let us go to the definition first. Now what is the definition of a logarithm? Suppose if a is the positive real number other than 1 and y is equal to a to the power of x. So if a is a positive real number other than 1 and if y is equal to a to the power of x, then this x is called the logarithm of y to base a. If y is equal to a to the power of x, then this x, the power x is called the logarithm of y to base a, denoted as x is equal to log y to base a. So the base will remain the same. So if you write the logarithm for this, if y is equal to a to the power of x, then this x is called the logarithm of y to base a. That is denoted as x is equal to log y to base a. So if y is equal to a to the power of x, then x is equal to log y to base a is called the logarithm of the given function. That is, if a is a positive real number other than 1 and y is equal to a to the power of x, then this power x is called as the logarithm of y to base a, denoted as x is equal to log y to base a. That is, if y is equal to a to the power of x, then this x is called the logarithm of y to base a. If y is equal to a to the power of x, then this x is equal to log y to base a is called the logarithm of a given function. Now, suppose, let us have a note. If a is any non-zero real number, then a to the power of 0 is always equal to 1. You know a to the power of 0 is always equal to 1. If you write the logarithm for this, 0 is equal to log 1 to base a. So keep it in mind, logarithm of 1 to base a is always equal to 0. The reason is a to the power of 0 is 1. Since a raised to 0 from law of indices you might have been studied, a to the power of 0 is 1. So you know a raised to 0 is 1. So according to the definition, if you put the logarithm for this, 0 is equal to log 1 to base a. That means logarithm of 1 to base a is always equal to 0. Listen, if a to the power of 1 is equal to a, this implies this 1 is the logarithm of a to base a. That means if a to the power of 1 is equal to a, this implies logarithm of a to base a is equal to 1. That means logarithm of any number to the same base is always equal to 1. Log a to base a is 1, log b to base b is equal to 1. So logarithm of any number to the same base is always equal to 1. That is, log a to base a is equal to 1. This is very important concept. The logarithm of any number to the same base is always equal to 1. Okay. Now let us come to the laws of logarithm. So there are few laws like laws of indices. We have logarithmic laws. These laws are very important. So in the examination they may ask one question for 3 marks, any proof to prove that log m into n, m by n, like that. So let us come to the first law. First law of logarithm states that logarithm of mn to base a is always equal to log m to base a plus log n to base a. Logarithm of mn to base a is always equal to log m to base a plus log n to base a. Now let us come to the proof. Let us consider, let logarithm of m log m to base a is equal to, let us consider this as x. So according to the definition of logarithm, this implies a to the power of x is equal to m. So a power x is equal to m. So m is the logarithm of x to base a. Similarly, let us consider log n to base a is equal to y. This implies y, this n is equal to a to the power of y. A to the power of y is equal to n. Similarly, consider logarithm of mn to base a is equal to z. This implies this mn is a logarithm of mn, that is mn is a logarithm of z to base a, that is, so mn can also be written as a to the power of z. A to the power of z is equal to mn. This is very important concept. See here, let us assume that x, y, z, a to the power of m is equal to x, which implies a power x is equal to m. Similarly, log n to base a is equal to y, a power y is equal to n, and logarithm of mn to base a is equal to z, which implies a to the power of z is equal to mn. Now let us consider from this mn, now from mn is equal to mn is equal to a to the power of z. Now substitute the values of m and n. What is m? What is m? M is equal to a to the power of x, and into what is n? N is equal to a to the power of y is equal to a to the power of z. So according to law of indices, a power m into a to the power of n is a to the power of m plus n. This can be written as a to the power of x plus y is equal to a to the power of z. That is, a power z is equal to a to the power of x plus y. So whenever the bases are equal, the powers is also equal. So therefore, the bases are equal. This can be written as z is equal to x plus y. Z is equal to x plus y. Now substitute the value of z. What is z you have taken? Z is equal to log mn. Logarithm of mn to base a is equal to, what is x? X is equal to log m to base a. Logarithm of m to base a plus, what is y? Log n to base a. Log n to base a. What is say? So logarithm of m into n is equal to log m to base a plus log n to base a, which is the required proof. That is the first answer. Okay, first law of logarithms. So listen, let us consider log m to base a is x, which implies a power x is m. Log n to base a is equal to y, which implies a to the power of y is equal to n. Log m into n to base a is equal to z, which implies a power z is equal to mn. Now consider this mn is equal to a power z. M is a power x, n is equal to a power y is equal to a raised to z. According to law of indices, a power m into a raised to n is a to the power of m plus n. A to the power of x into a to the power of y is a to the power of x plus y is equal to a power z. Whenever the bases are equal, the power is also equal. Then these two gets cancelled. Z is equal to x plus y. What is z? Log mn is equal to, what is x? Log m to base a. That is y, log n to base. So therefore, logarithm of mn to base a is equal to log m to base a plus log n to base a. Similarly, if it is like this, logarithm of m into n into p etc. to base a, this can be written as log m to base a plus log n to base a plus logarithm of p to base a plus number of terms. So log m into n into p is log m plus log n plus log p etc. number of terms we will get. That's it. This is first law of logarithms. Okay, hope you followed. Now let us come to the next law, second law. What is second law? To prove that, this is also important one. So logarithm of m by n to base a is equal to log m to base a minus log n to base a. This is also similar type. Let us consider this as x, y and z and simplify. Now let us come to the proof. Let logarithm of m to base a is equal to x, which implies a to the power of x is equal to m. Similarly, log n to base a is equal to y, which implies a to the power of y is equal to n, and logarithm of m by n to base a is equal to z, which implies a power z is equal to m by n. These are the things. So let us consider log m to base a is x, which implies a power x is m. log m to base a is equal to y, a to the power of y is equal to n, log m by n to base a is equal to z. So therefore this is nothing but z is a power z is equal to m by n. Now let us consider from this. From m by n is equal to a to the power of z. Substitute the values of m and n. What is m? A power x. What is n? A power y. So a to the power of x divided by a to the power of y is equal to a to the power of z. Since you know, according to law of indices, a to the power of m by a to the power of n is also equal to a to the power of m minus n. So this is nothing but a to the power of x minus y is equal to a power z. So a power z is equal to a to the power of x minus y. Whenever the bases are equal means then the powers are also equal, a gets cancelled, therefore z is equal to x minus y. Now substitute the value of z, x and y. What is z? Log m by n. What is y? Log n by a. What is x? Log m. So therefore z is equal to logarithm of m by n to base a is equal to, what is x? Log m to base a. What is y? Log n to base a, which is the required proof. So logarithm of m by n to base a is equal to log m to base a minus log n to base a. So therefore logarithm of m by n to base a is equal to log m to base a minus log n to base a, which is the required proof. That is the second law. So first law is logarithm of m into n to base a is log m plus log n. If it is into means we will get plus. If it is division, log m by n is equal to log m minus log n to base a. Okay, right. Hope you followed. These two are very, very important theorems indeed. Now let us come to the third one. Now what is the third one? This is also important. Third law of logarithms. Logarithm of m to the power of n to base a is equal to n log m to base a. Logarithm of m to the power of n to base a is equal to n log m to base a. The power comes here, n into log m to base a. Now let us come to the proof. Let us consider, let logarithm of m to base a is equal to x, which implies a to the power of x is equal to m. Now m is equal to a to the power of x. Raising the power to n, raising the power to n, this is m to the power of n can be written as a to the power of x whole raised to n, raising the power to m. So this is m to the power of n can also be written as, there is one law of indices, a to the power of m whole raised to n is equal to a to the power of m into n. So this can be written as a to the power of n into x is nx, a to the power of nx. Okay. Now since what is here? So therefore a to the power of nx is equal to m to the power of n. Since a to the power of nx is equal to m to the power of n means, then according to the definition of the logarithms, so the logarithm of m to the power of n to base a is equal to n into x. Okay, by definition. By definition of logarithm. So if a to the power of nx is equal to m to the power of n means, then this m to the power of n to base a is equal to n. So nx is the logarithm of m to the power of n to base a. Now therefore logarithm of m to the power of n to base a is equal to n into, substitute the value of x. What is x we have taken? X is equal to log m to base a, logarithm of m to base a. So what do you say? Therefore logarithm of m to the power of n to base a is always equal to n log m to base a, which is the required answer. That's it. So log m to the power of n is equal to n log m to base a. See, very simple. Let us consider log m to base a as x. So as usual, a to the power of x is equal to m. So m is equal to a power of x, raising the power to n, since it is required, n is the power required. So raise the power to n, m to the power of n is equal to a to the power of x raised to n. Since law of indices, a to the power of mn is a raised to m into n, m to the power of n is a to the power of nx. So a to the power of nx is equal to m to the power of n minus, by definition of logarithm, this nx is the logarithm of mn to base a, that can be written as logarithm of m to the power of n to base a is equal to nx. So logarithm of m to the power of n to base a is equal to n into, substitute the value of x, x is equal to log m to base a. So therefore log m to the power of n to base a is equal to n into log m to base a. This is very, very important theorem, that is law, third law of logarithms. Now, let us come to the fourth law, that is log m to base n is also equal to log m to base a divided by log n to base a. This is also called as a base change rule. Base change rule. This is called base change rule or base change law. Base changing the base to e. Change the base to e. A. Change the base to a, you will get log m to base a divided by log n to base a. Okay. Go to the proof. We will do the proof for this. So what is to prove? Log m to base n is equal to log m to base a divided by log n to base a. That is called base change rule, changing the base to a. Now let us consider the left hand side. Let logarithm of m to base n is equal to x. Let us consider this. Let log m to base n is equal to x. So if you take, if you remove the logarithm for this, then n to the power of x is equal to m. M is equal to n power x. Okay. Now that is m is equal to n to the power of x. Now taking log on both sides. Taking log on both sides to base a. Okay. So if you take log on both sides, then what you will get? Logarithm of m to base a is equal to logarithm of n to the power of x to base a. Right. Now, if you apply third law of logarithms, this left hand side logarithm of m to base a as it is, using third law, log m to the power of n is n log m, x log n to base a, using third law of logarithm. See, log m to base a is equal to log m to the power of n. Instead of n, it is x. X log n to base a. X log n to base a. Right. Now, just get the value of x from this. What is x from this? So, that is logarithm of m to base a divided by logarithm of n to base a is equal to x. That's all. Now, substitute the value of x. What is x we have taken? X is equal to log m by n. That's it. So, that is logarithm of m to base a divided by logarithm of n to base a is equal to, what is x? Logarithm of m to base n. So, put it in order. Therefore, logarithm of m to base n is also equal to log m to base a divided by log n to base a. This is called your base change rule. That's it. Very simple. Okay. Hope you followed. Let us consider log m to base n as x. So, n to the power of x is equal to m. M is equal to n power x means taking log on both sides, that is to base a. Logarithm of m to base a is equal to logarithm of n to the power of x to base a. Using third law of logarithms, log m to the power of n is n log m. The power will come here. That is log m to base a is equal to x log n. X log n to base a. Now just very simple, get the value of x from this. What is x? Just transfer this to the denominator. X is equal to log m to base a divided by log n to base a. Substitute the value of x. What is x? Log m to base n. That's it. So, what is the required answer? This is the required answer. Therefore, logarithm of m to base n is equal to log m to base a divided by log n to base a. This is called your base change rule. Okay. Very important concept indeed. So, therefore, logarithm of m to base n is also equal to log m to base a divided by log n to base a. Now, this is very important. Suppose if you want to change to any base, for example, log m to base n, if you want to change to base b, then we can write log m to base b divided by log n to base b. This is called your base change rule. Now, let us come to the very, very important concept. Logarithm of a to base b, logarithm of a to base b can also be written as changing the base to a, log a to base a divided by log b to base b. Since we know what is logarithm of a to base a, logarithm of any number to same base is equal to 1, log a to base a is equal to 1 divided by log b to base a. That means logarithm of a to base b can also be written as 1 over logarithm of b to base a. So, here log a to base a and log b to base b, changing the base to a, then log a to base a is 1 divided by log b to base b. That is changing the base to a. Change the base to a. Similarly, let us come to the second note. log a to base b into log b to base c is also equal to log a to base c. See here, according to the definition, according to base change rule, log a to base b into logarithm of base b to base, logarithm of b to base c can also be written as changing the base to c. Let us change the base to c. Let us change the base to c. So then this can be as log a to base c divided by logarithm of b to base c into changing the base to c, logarithm of b to base c divided by logarithm of c to base c. What happens here? Log b to base c, log b to base c gets cancelled, and what is left over in the numerator is log a to base c, log a to base c divided by log c to base c is 1. So this is equal to logarithm of a to base c. That's it. Logarithm of a to base c. Okay. So logarithm of a to base b into logarithm of base to c, that is log a to base b into log b to base c is also equal to logarithm of a to base c. This b and b gets cancelled. Now this is the note based on this base change rule. Now let us take few problems for 1 mark. So these are all 1 mark questions, short answer questions. Now express the following in the logarithmic forms. 2 to the power of 5 is equal to 32. We know 2 power 5 is equal to 32, and according to the definition, since if a to the power of x is equal to m, which implies x is equal to logarithm of m to base a, right? X is the logarithm of m to base a. So what is given here? 2 to the power of 5 is equal to 32 means, therefore we can write 5 is equal to logarithm of 32 to base 2. That's it. That is logarithm of 32 to base 2 is equal to 5. That is the meaning. So therefore we can write logarithm of 32 to base 2 is equal to 5. Now let us come to the second problem. This is first one, and the second one, 3 to the power of minus 2 is equal to 1 by 9. Now this can also be written as, since a to the power of x is equal to m means here m is equal to minus 2 is equal to logarithm of x is minus 2 is equal to logarithm of m is 1 by 9 to base 3. So therefore we can write logarithm of 1 by 9 to base 3 is equal to minus 2. That's all. This is the required answer. That's it. Okay. Logarithm of 1 by 9 to base 3 is equal to minus. Now let us come to this. So this is a to the power of x is equal to n. According to the definition, x, what is x here? Minus 2 is equal to logarithm of m. M is nothing but, what is m here? 0.04 to base 5. So therefore we can write logarithm of 0.04 to base 5 is equal to minus 2. This minus 2. That's it. Okay. This is how we are going to write the logarithm for the exponent form. Let us come to the next set of problem. Express the following in the exponential form. Here the logarithmic form are given. We have to express in an exponential form. Since you know what is the exponential form, a power x is equal to m means x is equal to logarithm of m to base a. The base will remain the same. So the a power x is equal to m means x is the logarithm of this number m to base a. So this implies, what is the base here? Here base is 9. 9 remains the same. 9 to the power of 2 is equal to 81. That's it. See, a to the power of x is equal to m means x is equal to log m to base a. What is x? X is nothing but a to the power of x. So here x is equal to log m to base a is given. X is equal to log m to base a means the base will remain the same. A to the power of x, that is 2 to the power of 2 is equal to 81. So therefore we can write 81 is equal to 9 square for the first one. Right. Now let us come to the second one. Logarithm of 0.01 to base 10 is equal to minus 2. Again this can be written as, what is the power base here? Base will remain the same. 10 to the power of, yes, a to the power of x. What is x here? Minus 2 is equal to this 0.01. That's it. So x is equal to log m to base a. X is equal to log m to base a. So that is nothing but a to the power of x. A is base to the power of x, minus 2 is equal to 0.01. That's it. Okay. So this can be written as 10 to the power of minus 2 is equal to 0.01. You know what is 10 to the power of minus 1? That is 0.01. Here also 9 square is 81, that you know already. Now come to this problem. Logarithm of 1 by 4 to base 2 is equal to minus 2. This implies, what is the base here? Base is 2 to the power of minus 2 is equal to 1 by 4. So log m to base a is equal to n. So base is 2 to the power of x minus 2 is equal to 2 to the power of x is equal to 1 by 4. So you know the value of 2 to the power of minus 2 is 1 by 4. That's it. So we can write 2 raised to minus 2 is equal to. So this is how we are going to express the exponential form to the logarithmic form and logarithmic forms to the exponential forms. Now let us come to the very simple problem. Now let us solve for x. This is very simple. Solve square root of 32 to base 2 is equal to x. So this can be written as, according to the definition, what is the definition? Logarithm of m to base a is equal to x implies a to the power of x is equal to m. So what is this? This can be written as 2 to the power of x is equal to root 32. So 2 power x is equal to 32 can be written as 32. 2 into 2 into 2 into 2. 2 2s are 4, 4 2s are 16 into 2. That is 2 to the power of 5. Okay, this can be written as square root of 2 to the power of 5. This is 2 power x is equal to 2 to the power of 5. Square root means 1 by 2. 2 power x is equal to 2 to the power of 5 by 2. So whenever the bases are same, then the powers are also equal. Therefore, x is equal to 5 by 2. That's it. Okay. See here, very simple. What is given? Logarithm of 32 to base 2 is equal to x. So according to the definition of logarithms, log m to base a is equal to x implies a to the power of x is equal to m. So a to the power of x is 2 power x is equal to root 32. 2 power x is equal to square root of 32 can be written as 2 raised to 5. So root is nothing but 1 by 2. 2 to the power of 5 by 2. Bases are same. Therefore, x is equal to 5 by 2. 5 by 2. That's it. Now let us come to the next problem. Same type. Solve for x. Logarithm of 10 to base x is equal to 0.1. So again, according to the definition, logarithm of m to base a is equal to x implies a to the power of x is equal to m. So here a to the power of x, 0.1 to the power of x is equal to 10. Okay. So this 0.1 can be written as 1 by 10 to the power of x is equal to 10. 1 by 10, this is nothing but 10 to the power of minus 1 whole raised to x is equal to 10 power 1. This is 10 to the power of minus x is equal to 10 power 1. So whenever the bases are same, power is also equal. Minus x is equal to 1. So therefore x is equal to minus 1. That's it. This is the simple answer. Now see, very simple. If you remove logarithm 0, if you convert this to the exponential form, 0.1 power x is equal to 10. 0.1 is nothing but 1 by 10. 1 by 10 can be written as 10 to the power of minus 1 power x is 10 to the power of minus x is equal to, this is 10 power 1. Bases are same, therefore minus x is equal to 1 means x is equal to minus 1. Now let us come to the next problem. What is the problem given? Logarithm of 625 to base x is equal to 4. Same. So if you convert this, this can be written as, according to the definition, logarithm of m to base a is equal to x implies a to the power of x is equal to m. So this implies x to the power of 4 is equal to 625. So x power 4 is equal to, just write down the factors for 625. 625 can be written as 5 into 5 into 5 into 5. 5 5s are 25. 25 into 5 is 125. 125 into 5 is 625. This is 5 to the power of 4. 5 5s are 25. 25 into 5 is 125. 125 into 5 is 624. So 625 can be written as 5 to the power of 4. Okay. So whenever the powers are equal means, therefore the base is also equal. X is equal to 5. That's it. X is equal to 5 is the required answer. So this is how we are going to solve the problem. See here, log of 625 to base x is equal to 4 means, according to the definition of logarithms, log m to base a is equal to x implies a to the power of x is equal to m. So this is base x to the power of 4 is equal to 625. 625 can be written as 5 to the power of 4. Whenever the powers are same means the bases are equal, here x is equal to 5. That's it. So x is equal to 5 is the required answer for this problem. Hope you followed. Okay. So these are few problems and the laws of logarithms. So 3 laws as well as the problems based on the logarithmic laws. Okay. Now that's all regarding today's session. Let us meet with the different concepts in the next class. Thank you. Thank you very much.